Have you ever really thought about what's happening behind the screen when you're playing chess online? You've got millions of people all over the world battling it out 24/7. Well, today we're going to pull back the curtain and look at the actual engineering blueprint that makes it all work. We're talking from the very first move all the way to checkmate, but at a massive global scale.
All right, let's start with just one number, a really big one. At any given moment, a popular chess site is dealing with about 100,000 of these.
Yeah, you heard that right. 100,000 concurrent games. We're talking hundreds of thousands of players, all at the same time, and every single one of them expects their move to be instant. They expect their clocks to be perfectly in sync, and of course, they expect every game to be saved without a single hiccup. That's a huge ask.
So how on earth do you build a system that can handle that? That's the million-dollar question, right? Well, that's exactly what we're going to break down. We're going to look at the architectural blueprint that makes this whole thing possible. All right, let's get into it.
Okay, so first things first. Just like in chess, you need a plan. Before you write a single line of code for a project this big, you have to lay down the rules of the game. You've got to define what the system has to do, no excuses, and what promises it's making to every single player.
So think of it like this. You've got two sides of the same coin here. On the left, you have the what, the functional stuff. These are the things you actually see and click on. You know, playing a game, checking your game history, spectating. But then on the right, you have the how well, the non-functional requirements. And honestly, this is where the real magic is. This stuff is invisible, but it's what makes or breaks the whole experience. We're talking low latency, meaning it's fast, high availability, it's almost never down, and absolute consistency, the game is always right. Get this part wrong, and nobody cares how cool your features are.
Okay, so to handle all of this, you don't just build one giant, clunky building. That would be a disaster. No, the smart way to do it is to think like a city planner. You design a whole digital metropolis with different districts that are specialized for different jobs. Let's pull up the map of this city. So check this out. Our digital city has a few key spots. First, you've got the API gateway. This is like the grand central station, the main entrance where all the traffic comes in and gets directed. Looking for a match? You're sent to the matchmaking service, which is kind of like a giant stadium where opponents are paired up. The actual games? They happen in the game service. Think of these as thousands of individual playing fields. And what connects everyone instantly? That's the real-time layer, a super fast monorail zipping information back and forth. And finally, you have the persistent service. This is the city's massive library, meticulously recording every single event that ever happens.
All right, now let's zoom in a bit. Let's talk about that high-speed monorail, that real-time layer. Because honestly, the whole feel of a live game, that feeling of instant back and forth, it all comes down to one absolutely critical piece of tech. It's basically the heartbeat of every single match. And that technology is called a WebSocket. Here's a super simple way to think about it. Normally, when you're on a website, your computer has to keep bugging the server, like, hey, did they move yet? Is it my turn? Anything new? Over and over again. It's inefficient. A WebSocket is different. It opens up a dedicated two-way street between you and the server. The connection just stays open. So the second your opponent makes a move, the server can push it directly to you. No asking, no waiting, it's just instant. So let's trace the journey of a single chess move, which happens in the blink of an eye. You make your move, and bam, it's sent through that WebSocket. The gateway immediately knows which game you're in and routes it to the right game server, which is basically your game's personal referee. That server instantly checks if the move is legal, updates the board, logs it, and then broadcasts it right back out to your opponent and anyone who's watching. The craziest part? This whole round trip takes less than 200 milliseconds. It's unbelievably fast. And this whole one server per game thing, it points to probably the most important design choice they made. It's what's called a single authoritative server. It means for every game, there is one and only one source of truth, one referee. This is so important. It completely eliminates any chance of conflicting moves, of cheating, of the game getting out of sync. The state of the board is always 100% correct because there's only one entity in charge of making the calls.
Okay, so live gameplay is one thing, but what about after the game is over? A great platform needs a perfect memory, right? It has to remember every single game you've ever played, for you to analyze, for replays, for your rating. So how does the system store billions of moves without grinding to a halt?
Well, it uses this really smart two-part strategy. If you look at this simplified table, the main database only holds the essential info, like who played, who won, stuff like that. It's small, it's searchable, it's super fast. But the actual move-by-move notation for the whole game, what chess nerds call a PGN file, that's stored somewhere else, in a cheaper, bulk storage system. The main database just holds a little pointer to it. This is genius because it keeps the main database incredibly lean and fast, so when you ask for your game history, it comes up instantly.
So, this blueprint we've laid out, it works great for one game. It even works great for 1,000 games. But how do you scale it up to handle millions of players from all over the world all at once? How do you go from a local club to a global arena? This is the final and maybe the biggest piece of the puzzle.
The secret is something called horizontal scaling. Instead of trying to build one single massive, ridiculously expensive supercomputer, which is called vertical scaling, the system is designed to grow outwards. It uses hundreds or even thousands of smaller, cheaper, off-the-shelf servers. And as more people join, they just add more servers to the pile. The system is smart enough to automatically divide all the games across this huge fleet of machines. It's like instead of building a skyscraper, you just keep adding more buildings to your city. It's way more flexible and ultimately is what allows it to handle massive, sudden spikes in traffic without even blinking. So why does any of this techie stuff matter to you? Well, here's the takeaway. Every single one of these design choices you just saw directly impacts your experience. This architecture is the reason you don't get lag when you're about to make a critical move. It's why the platform is basically always online. It's why matchmaking is fair and fast, and why you know your entire game history is safe. None of it is an accident. It's all carefully engineered. And really, it all comes full circle. It all goes back to those non-functional requirements we talked about at the very beginning. The whole point of this massive, complex system is to deliver on those promises, to keep your moves feeling instant, to keep the site up and running practically all the time, and to make sure every single game is 100% accurate and fair.
You know, when you build a foundation this strong, you're not just solving today's problems. You're building a platform for the future. This kind of robust, scalable architecture makes all sorts of new things possible, like advanced anti-cheat systems, smarter AI opponents, maybe even huge global tournament systems. It really makes you wonder, with a foundation this solid, what's coming next?